Welcome to Aurora Chemistry for everyone. Let us see how to write Lewis dot structure of PO4 3- phosphate ion. To write Lewis dot structure, certain steps are there. We need to follow the steps. So if you look at the step 1 is skeletal structure. When you draw the skeletal structure, if you see the step 2, the center should be less electronegative atom. In phosphate ion, in PO4 3-, oxygen is highly electronegative. So we are going to write phosphorus in the center. So phosphorus in the center, and then for oxygen, we are going to draw just around the phosphorus. Okay, so then if you see the third step, count valence electrons. So we go to count valence electron. So to count valence electrons, you know that phosphorus in 15th group. So the valence electron of phosphorus is 5. So only one phosphorus atom. So we go to write 5. Then oxygen, there are 4 oxygen atoms are there. Oxygen valence electron 6. So 4 multiplied by 6. Plus this is polyatomic anion. So we go to add 3 electrons extra. So we are going to add 3 electrons. If it is a cation, you should subtract. Now if you add all together, then you will get 32 valence electrons. So there are 32 valence electrons in phosphate ion. Now come to step 4, single bond between all the atoms. So we go to draw single bond between all the atoms. Then step 5, double or triple bond for central atom. So now we go to draw double or triple bond. Why we are going to draw double or triple bond means to give octet configuration, because atoms in octet configuration is highly stable. But how do we come to know about that, whether this phosphorus atom will get double or triple bond? For that, you should draw that electron dot structure for phosphorus. Phosphorus valence electron 5. So 1, 2, 3, 4, 5. So 2 lone pair electrons are present, but phosphorus in third period. So elements in third period or after third period, there is availability of d orbital, so they can expand its orbital for bond formation. So phosphorus can make 5 covalent bonds, because if you see the steps, there are some exceptional cases are there, except expanded sulfur, phosphorus, chlorine, bromine, iodine, because expanded means they can make more than 8 electrons. They do not follow octet configuration. So we'll see, listen here, we can draw now 5 covalent bonds. 5 covalent bonds. See, already 4 bonds are here. So we are going to make one more bond. So one more bond is over. Now come to step 6, octet for highly electronegative atom. Then if you see that step 7, duplet for hydrogen. Anyhow here hydrogen is not there. So we are going to give octet for highly electronegative atom, that is oxygen. Already see 1 bond, 2 electrons. 2, so 4, 6, 8. So octet configuration for this oxygen is over. Now let us move to this oxygen. 2, 4, 6, 8. Now come to this terminal oxygen. Here already 2 double bond. So 4 electrons. So 6, 8. So octet for this oxygen is also over. Now come to here. Only single bond. So 2 electrons. So 4, 6, 8. So octet is completed. Now come to check that phosphorus 2, 4, 6, 8, 10. So 10 electrons are present. But phosphorus in exceptional case. So it can take more than 8 electrons. So since now let us check that 32 valence electrons are present or not. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So 32 valence electrons are present. So this Lewis dot structure for phosphate ion is absolutely correct. But this is polyatomic ions. So whenever cation, anion or polyatomic ions are present, we should write that structure by enclosing with brackets, and that charge is there is 3 minus charge, that you should write it in the topmost right side. So this is the Lewis dot structure of phosphate ions. All these steps, if it is in the form of mnemonics, it is easy, isn't it? So for that, just remember this mnemonics. A skeletal in the biology lab center: count single, double, triple, octet, duplet, expanded, deficient, odd guys in the classroom. See, the highlighted one represent the steps. So if you remember the mnemonics, you can solve any type of Lewis dot structure. Thanks for watching.